The cosmos is an endless sea of darkness. Sprinkled across this black canvas are points of light. We call them stars, distant suns burning with unimaginable fury. Around these stars dance planets, shrouded in shadow and mystery. One such world, a giant cloaked in emerald light, beckons us closer. Its name is Uranus, and its story is one of profound enigma. Uranus, the seventh planet from our sun, is a world of frigid beauty. It is a realm of perpetual twilight where temperatures plummet to hundreds of degrees below freezing. Yet, Uranus holds a secret, a mystery that has tantalized astronomers for centuries. The answer, as we are about to discover, takes us on a journey deep into the heart of a planetary giant. The green glow of Uranus is not merely a visual spectacle. It is a scientific puzzle that has captivated astronomers for generations. Unlike Jupiter or Saturn, Uranus's emerald hue is subtle, almost haunting. It speaks of a world shrouded in secrets. The first hints of this enigma emerged in the late 18th century. William Herschel stumbled upon Uranus by accident. He mistook it for a comet, but it was a new planet. The quest to understand Uranus's green glow has driven astronomers to develop ever more sophisticated instruments and techniques. No longer content with simply observing the planet from afar, scientists have launched ambitious missions to study Uranus up close. These missions, equipped with cutting-edge technology, have allowed us to pierce the veil of distance and begin to unravel the secrets of this enigmatic world. In 1986, the Voyager 2 spacecraft made its historic flyby of Uranus, capturing the first close-up images of the planet and its moons. The data sent back by Voyager 2 revolutionized our understanding of Uranus. It revealed a world of complex atmospheric dynamics and a surprisingly active magnetic field. More importantly, Voyager 2 provided the first detailed observations of Uranus's atmosphere. These observations confirmed the presence of methane, a gas known to absorb red light and scatter blue and green light. This discovery provided a crucial clue to the origin of the green glow. Yet, the story does not end there. The Voyager 2 flyby, while groundbreaking, was just the beginning. It raised as many questions as it answered, fueling a new generation of scientists eager to delve deeper into the mysteries of Uranus. The year was 1781. William Herschel aimed his handcrafted telescope at the constellation Gemini. Little did he know, destiny had other plans. A point of light out of place caught his eye. It moved, slowly but surely. Herschel mistook it for a comet, but its orbit was too circular. He had discovered a new planet, Uranus. Section 2. A Century of Speculation. Grasping at Gaseous Phantoms. The decades following Uranus's discovery were marked by both excitement and frustration. Astronomers armed with increasingly powerful telescopes eagerly trained their sights on the newly found world. They yearned to unlock the secrets hidden beneath its pale green veil. Yet, Uranus, distant and dimly lit, guarded its secrets jealously. The green glow, a subtle whisper across the vast gulf of space, offered tantalizing but frustratingly vague clues. Theories abounded, each attempting to explain the unusual hue. Some scientists speculated that Uranus's atmosphere was rich in copper or other minerals, lending it a greenish tint. Others imagined vast swamps of extraterrestrial vegetation, their emerald canopies reflecting the distant sunlight. These early hypotheses, while imaginative, were ultimately limited by the technology of the time. Spectroscopy, a technique for analyzing the light emitted or absorbed by celestial objects, was still in its infancy. Without the ability to decipher the chemical fingerprints hidden within Uranus's light, astronomers were left to grapple in the dark. Their theories, like phantoms in the night, lacked the substance to withstand the harsh light of scientific scrutiny. The true nature of the green glow remained elusive, a celestial enigma waiting for the day when technology would catch up with human curiosity. Section 3. The Dance of Light and Gas, Unraveling the Spectrum's Secrets. The late 19th and early 20th centuries witnessed a revolution in astronomy. Spectroscopy blossomed into a powerful tool for probing the cosmos. By splitting starlight into its component colors, astronomers identified chemical elements in stars and nebulae. This ability was pivotal in understanding Uranus's green glow. They made a startling discovery. The spectrum of Uranus's light was not what they expected. It lacked the telltale signatures of copper or other minerals. Instead, dark bands revealed the fingerprints of gases. Uranus was a gas giant, its atmosphere composed of elements that danced with light. Section 4. Methane's muted song, a clue in the green's embrace. Methane emerged as a prime suspect in the green glow of Uranus. Methane absorbs red light efficiently. Sunlight passing through methane-rich atmosphere absorbs red wavelengths. The remaining blue and green light scatters, giving Uranus its hue. Methane's role in Uranus's color was a major breakthrough, yet the story was far from over. Imagine Uranus as a celestial canvas, a sphere of swirling gases painted with hues of turquoise and emerald. This canvas, however, is far from static. It is a dynamic, ever-changing landscape shaped by powerful forces and shrouded in a veil of mystery. To understand the green glow, we must first journey into the heart of Uranus's atmosphere. Unlike Earth, Uranus's gaseous envelope is a gradient, transitioning from thin clouds to a dense fluid. Methane, with its light-absorbing properties, plays a starring role. Sunlight encounters methane molecules which capture red light. The remaining blue and green photons paint the planet's hue. High above Uranus's swirling clouds lies a region shrouded in mystery, the methane haze. This ethereal veil is composed of complex hydrocarbons, formed from the breakdown of methane by sunlight. These hydrocarbons condense into tiny particles, forming a thin global haze that encircles the planet. The methane haze plays a crucial role in shaping Uranus's appearance. It acts as a filter, scattering sunlight and contributing to the planet's brightness. The haze influences the way we perceive the green glow. The precise composition and structure of the haze remain active areas of research. Scientists believe that the haze particles vary in size and complexity depending on altitude and exposure to sunlight. To comprehend Uranus's green glow, we must understand light. Light is electromagnetic radiation traveling in waves. These waves have different wavelengths, corresponding to colors. Red light has longer wavelengths, blue light shorter. Sunlight scatters when it hits particles, changing direction. Rayleigh scattering is more efficient for shorter wavelengths. Methane in Uranus's atmosphere absorbs red light. This results in Uranus's ethereal green hue. Section 4. Beyond the green subtleties in the spectrum's whisper. While the presence of methane and Rayleigh scattering explains the dominant green hue of Uranus, the story doesn't end there. A closer look at the planet's spectrum, the detailed breakdown of its reflected light, reveals subtle variations in color across its disk. These variations, like whispers in the wind, hint at a more complex and dynamic atmosphere than initially meets the eye. For example, Uranus's poles often appear slightly bluer than its equatorial regions. This subtle shift in color suggests differences in atmospheric circulation and haze properties between these regions. Furthermore, spectroscopic observations have detected trace amounts of other gases in Uranus's atmosphere, such as hydrogen sulfide and carbon monoxide. While these gases are present in far smaller quantities than methane, they can still influence the planet's color, particularly at specific wavelengths. These subtle variations in color, often overlooked but nonetheless significant, serve as crucial clues for scientists piecing together the intricate workings of Uranus's atmosphere. They remind us that even in the seemingly uniform expanse of a giant planet, hidden complexities and dynamic processes are constantly at play. Section 5. A Symphony of Gases Unveiling the Atmospheric Orchestra. Uranus's atmosphere, far from being a static, homogeneous envelope, is a dynamic and complex system, more akin to a symphony orchestra than a solo performance. Methane, while a key player, is just one instrument in this celestial ensemble. Alongside it, other gases, albeit in smaller roles, contribute to the planet's unique sonic signature. Hydrogen and helium, the lightest and most abundant elements in the universe, form the backbone of Uranus's atmosphere. These gases, largely transparent to visible light, provide the stage upon which the other actors, like methane, perform their chromatic dance. Helium, in particular, plays a crucial role in shaping the planet's thermal structure. Its high thermal conductivity helps to distribute heat more evenly throughout the atmosphere, preventing extreme temperature gradients. Then there are the trace gases, the supporting cast of this atmospheric production. Ammonia, hydrogen sulfide, and water vapor, though present in minute quantities, can condense into clouds at different altitudes, influencing the planet's overall brightness and potentially contributing to the subtle color variations observed across its disk. The interplay of these gases, each with its unique properties and behaviors, creates a dynamic and ever-changing atmosphere, a testament to the intricate and interconnected nature of planetary systems. Section 1. A New Lens on Planetary Formation, Uranus's Gaseous Tail. The emerald glow of Uranus, deciphered through the lens of science, does more than reveal the secrets of a distant world. It provides a fresh perspective on the very process of planetary formation, challenging long-held assumptions about the birth of worlds. For centuries, our understanding of planetary formation was largely shaped by the familiar planets of our inner solar system, rocky bodies like Earth and Mars, sculpted by gravity and time. Uranus, with its massive gaseous envelope and icy depths, shattered this terrestrial bias. It revealed a different path in the grand narrative of planet formation, one where ice and gas, rather than rock and metal, play the leading roles. The abundance of methane in Uranus's atmosphere, a signature of its icy origins, hinted at a formation scenario far removed from the sun's warmth. It suggested a birth in the cold, distant reaches of the protosolar nebula, where ices could condense and coalesce, forming planetary embryos with a voracious appetite for gas. Uranus, in its very existence, forced us to expand our definition of a planet, to acknowledge the diversity and complexity of world-building and the vast expanse of the cosmos. Section 2. The Ice Giant's Enigma Challenging Assumptions of World Building. Uranus, alongside its near-twin Neptune, represents a class of planets known as ice giants. These enigmatic worlds, characterized by their deep icy mantles and massive gaseous envelopes, challenge our understanding of planetary interiors and the complex interplay of pressure, temperature, and composition. Unlike gas giants like Jupiter and Saturn, which are thought to possess relatively small, rocky cores, the internal structure of ice giants remains shrouded in mystery. Some models suggest that Uranus and Neptune may not have distinct cores at all, but rather a more gradual transition from gas to a supercritical fluid state, where the distinction between liquid and gas becomes blurred. This exotic internal structure has profound implications for our understanding of planetary magnetic fields, heat flow, and atmospheric dynamics. The unusual orientation of Uranus's magnetic field, tilted at a dramatic angle compared to its axis of rotation, further deepens the enigma. The study of ice giants, driven by insights gleaned from Uranus's green glow, pushes the boundaries of planetary science, forcing us to confront the limitations of our current models and embrace the vast unknown that lies hidden beneath the clouds of these distant worlds. Section 3. Beyond our Sun's Embrace. The Search for Distant Uranuses. The discovery of Uranus and its enigmatic green glow had a profound impact on our understanding of the solar system. But its significance extends far beyond the confines of our Sun's family. It has fueled a revolution in astronomy, the search for planets orbiting other stars, known as exoplanets. Prior to the discovery of exoplanets in the 1990s, our solar system was the only planetary system we knew. It served as the template for our understanding of how planets form and evolve. However, as we began to detect exoplanets, a startling realization dawned. Our solar system is far from typical. We discovered giant planets orbiting closer to their stars than Mercury orbits ours, planets with highly elliptical orbits, and even planets orbiting multiple stars. This newfound diversity of planetary systems forced us to rethink our assumptions about planetary formation and habitability. The study of Uranus, with its unique atmospheric composition and formation history, provided valuable insights for characterizing and understanding these distant worlds. Section 4. Exoplanetary Atmospheres Deciphering Alien Skies Through a Green Filter. The challenge of studying exoplanets is immense. These distant worlds, often light-years away, are incredibly faint and difficult to observe directly. However, astronomers have developed ingenious techniques to study their atmospheres, gleaning clues about their composition, temperature, and even weather patterns. One such technique, known as transit spectroscopy, involves observing the light from a star as an exoplanet passes in front of it, or transits. As the exoplanet transits, some of the starlight passes through its atmosphere, leaving behind subtle fingerprints in the spectrum of light that reaches our telescopes. By analyzing these spectral fingerprints, astronomers can identify the presence of specific gases in the exoplanet's atmosphere, such as water vapor, methane, and carbon dioxide. The study of Uranus's atmosphere, with its distinct methane signature, provides a valuable comparison point for interpreting the spectra of gas giants and ice giants orbiting other stars. The search for life beyond Earth is one of the most profound quests in science. While our current understanding of life is limited to what we know from Earth, the vast diversity of exoplanets suggests that life, if it exists elsewhere, could take on forms far beyond our imagination. Section 5. A Universe of Possibilities. Reimagining Planetary Diversity. The discovery of exoplanets, particularly those resembling Uranus and Neptune in size and mass, has ignited a renaissance in our understanding of planetary diversity. No longer confined to the familiar planets of our solar system, we now have a glimpse into a universe teeming with worlds stranger and more wonderful than we ever imagined. We've encountered hot Jupiters, gas giants orbiting scorchingly close to their stars, their atmospheres ablaze with unimaginable heat. We found super-Earths, rocky planets larger and more massive than our own, their surfaces potentially harboring vast oceans or towering mountain ranges. And we've discovered mini-Neptunes, planets with thick, hydrogen-rich atmospheres, straddling the line between gas giants and ice giants. This newfound diversity challenges our preconceived notions of what a planet can be, forcing us to expand our definition of habitable and to consider the possibility of life as we don't know it. The green glow of Uranus, once a mystery confined to our solar system, now serves as a beacon, guiding us towards a deeper understanding of planetary possibilities in the vast expanse of the cosmos. Section 6. The Methane Signature, a beacon in the search for life. The search for life beyond Earth is one of the most profound quests in science. While our current understanding of life is limited to what we know from Earth, the vast diversity of exoplanets suggests that life, if it exists elsewhere, could take on forms far beyond our imagination. In our search for extraterrestrial life, We often focus on finding planets within the habitable zone of a star, where temperatures are conducive to liquid water on the surface. However, the discovery of extremophiles, organisms that thrive in extreme environments on Earth, has expanded our view of where life might exist. Could life exist in the icy depths of a subsurface ocean on a moon orbiting a gas giant? Could it thrive in the clouds of a planet with a methane-rich atmosphere like Uranus? While we don't have definitive answers yet, the possibility is tantalizing. The presence of methane in Uranus's atmosphere, a potential biosignature, serves as a reminder that life, if it exists elsewhere, may not conform to our Earth-centric expectations. Section 7. Uranus, a stepping stone to cosmic awareness. The study of Uranus, once a niche field within astronomy, has blossomed into a multidisciplinary endeavor, drawing insights from planetary science, atmospheric physics, astrochemistry, and even astrobiology. The emerald glow of this distant world, once a source of mystery and speculation, has become a beacon, illuminating our understanding of planetary formation, atmospheric dynamics, and the vast diversity of worlds beyond our solar system. But the significance of Uranus extends beyond its scientific value. It serves as a powerful reminder of the vastness and mystery of the cosmos, humbling us in the face of the unknown and inspiring us to explore further. Each new discovery about Uranus, from the intricacies of its atmospheric circulation to the peculiar tilt of its magnetic field, expands our cosmic perspective, challenging us to question our assumptions and to embrace the unknown. Section 8. The Unanswered Questions. A universe of mysteries beckons. As we delve deeper into the mysteries of Uranus, we are reminded that every answer unveils a multitude of new questions. The emerald glow, while now partially understood, still holds secrets waiting to be unlocked. What is the precise composition and structure of Uranus's haze layer, and how does it vary over time? What is the nature of the planet's internal structure, and how does it generate its unusual magnetic field? Could Uranus harbor a deep subsurface ocean, and if so, could it support life as we don't know it? These unanswered questions beckon us to continue our exploration of this enigmatic world, to develop new technologies, and to push the boundaries of our scientific understanding. They remind us that the universe is a place of infinite wonder and endless discovery. The green glow of Uranus, once a symbol of our ignorance, has become a symbol of our insatiable curiosity, a testament to the enduring power of science to illuminate the darkest corners of the cosmos and to reveal the hidden wonders of the universe. Section 1. The emerald enigma endures lingering mysteries of an icy giant. We have journeyed far from the speculative musings of early astronomers to the groundbreaking discoveries of modern space exploration. We have pierced the veil of distance, unveiling the secrets behind Uranus's ethereal green glow. Yet, as with any profound encounter with the cosmos, our journey ends not with definitive answers, but with a deeper sense of wonder and a thirst for further exploration. The methane haze, a key player in Uranus's atmospheric drama, still holds its secrets close. The precise mechanisms by which sunlight interacts with methane and its byproducts, painting the planet with its subtle hues, remain active areas of research. The intricate dance of atmospheric circulation, influenced by the planet's extreme axial tilt and internal heat dynamics, continues to puzzle scientists. And what of the planet's deep interior, hidden beneath the swirling clouds and icy mantle? Does a solid core lie at the heart of this giant, or does a more exotic state of matter, a supercritical fluid defying our terrestrial intuition, hold sway? These lingering questions stand as a testament to the enduring mystery of Uranus, a reminder that even in the age of space exploration, the cosmos holds secrets yet to be revealed. Section 2. Uranus Beckons. A call to exploration and the promise of discovery. The mysteries of Uranus are not merely academic curiosities, they are a call to action, an invitation to embark on new voyages of exploration and to push the boundaries of human ingenuity. To truly understand this enigmatic world, we must send dedicated spacecraft back to the Uranian system, equipped with instruments capable of probing its atmosphere, mapping its magnetic field, and peering into its icy depths. Imagine a future mission, a worthy successor to Voyager's fleeting encounter, where a spacecraft equipped with advanced sensors spends years orbiting Uranus, meticulously mapping its atmospheric variations, studying its moons, and even deploying probes to sample the planet's atmosphere directly. Such a mission would revolutionize our understanding of ice giants, providing crucial insights into their formation, evolution, and potential for harboring life. But the allure of Uranus extends beyond its own enigmatic nature. It serves as a gateway to a broader understanding of planetary systems, both within our solar system and beyond. By studying Uranus, we gain insights into the formation and evolution of giant planets in general, including those orbiting other stars. Reflections in the Emerald Mirror. Our place in the cosmic tapestry. As we gaze upon Uranus, we reflect on our place in the grand tapestry of the cosmos. Uranus, with its extreme axial tilt and icy moons, reminds us of the universe's creativity. It shows we are part of something grander and more mysterious than we can comprehend. The emerald glow of Uranus reflects the boundless potential of the human spirit to explore.